Hello friends, good morning, good afternoon, and good evening. Welcome back to my channel and let's start with a new learning. Today I'm going to talk you on the CAN transport protocol. So what is this protocol, why it is used, and what is the need behind this protocol? So this is my agenda today. I will talk on the need, then we will see about the introduction part of this protocol, then different common terminologies used while handling this protocol. What is the TP.CM? That's a transfer protocol connection management. Then TP.DT, that's a transport protocol data transfer. Then we will see the different transfer sequences. Then we'll go for the data transfer without error. Then I will show you the and explain you the transfer sequence with error. Then we will see the broadcast data transfer, that is the broadcast announce messages. And the lastly, we see about the data transfer, that's the with maximum packets. So this is my plan actually. And this protocol is basically used for the multi-frame CAN messages to transmit the multi-frame messages. And it sends more than 8 bytes data over a CAN protocol. So let's see more in detail about this protocol. So what is the need for this protocol? Why it is needed? If we just look back on my knowledge sharing sessions on the CAN fundamentals, I explained the CAN data frame. So this is a standard CAN data frame. Here we're starting with the start of frame and the end of frame. What area and which area is more interested today is a data field. Here, if you see the data field, it is 8 byte. We cannot send the more than the 8 byte data in a single frame. This is a standard frame. But if I look for the extended frame, the situation is same. What is the benefit? You just have the identifier as a 29-bit, right? And the data field is again 8 byte. You cannot send the data more than the 8 byte. And if I talk about the J139 message format, here is the identifier field, which talks about the PGN source address, PDO format, PDO specific, everything. And here is the data field. Again, the data field length or the payload maximum is 8 byte. So just imagine or just understand that in the CAN and the standard extended as well as the standard CAN frame messages, including the J1 and 39 messages, what is the maximum payload? It's 8 byte. We cannot send the data more than the 8 byte. So there is a need to transmit and receive the message that may or may not fit into the single frame. In that case, we need a separate protocol. And this is this protocol, basically transport protocol. So due to the available bandwidth and the communication speed, it is not possible or not recommended to send the large amount of data in a single frame. So that was the intention behind when the CAN was invented. They considered the bandwidth, the communication speed, everything starting from the 125 kbps to 1 mbps. And they developed the protocol which could send 8 byte of the information over a single CAN frame. And that was the limitation. But now, uh, if you want to transmit the data more than the 8 byte, we need to talk about the CAN protocol, and that protocol is a transport protocol. So, but another reason why we were not transmitting more than 8 bytes earlier, this is because this may cause the miss out of the CAN messages as well. So it may increase the bus load on the networks. There are a lot many reasons before invention of this transport protocol. So all these reasons which I have defined here, which defines a need for invention or derivation of the CAN transport protocol. So let's talk about more into the introduction part. What is this protocol? So lesser than the 9 bytes of the data transfer, it shall be sent in the single CAN frame with a DLC set to the 8. When I say the DLC 8, that means you can send the 8 byte of the data in a single CAN frame. But ISO 157652 CAN, that is a transport protocol, is used to transport more than 8 bytes of data. But just try to understand, in a single frame, you are able to transmit only 8 bytes. But to have the more data, like if I wanted to transmit the information more than the 8 byte, and that is possible with this protocol. So this transmission mechanism allows to send up to the 1785 bytes over a CAN bus. And it gives it is not in the single frame. You need a multiple frames, but it gives the clear indications that this the one message is transmitting one message, not a frame. One message is transmitting maximum of 1785 data bytes during the communication from the transmitter node to the receiver node. And that is possible with this transport protocol. So, okay, so what is possible? The possible is here is a communication possible with broadcast as well as the destination address specific communication is possible with the help of this protocol. Now, let's talk more in detail about the transfer protocol connection management. There are a few terms which needs to be understand, and I will frequently use that terms are transfer protocol connection management, transfer protocol, data transfer. So let's talk about TP.CM. So transfer protocol connection management is used to set up and close out the connection of the multi-packets. Just imagine the transmitter want to transmit the data from one node to another node. And for that, if your data is more than 8 byte, you need to set up the connection, all right? And that job is done by this TP.CM. TP.CM setups and close out the connection between the transmitter and the responder. What is the role of the TP.DT? That's a transfer protocol data transfer. And this is used to communicate the data itself in the series of CAN data frames. And sometimes I refer that as a packets containing in the packetized data. The TP.CM setups the connection as well as close the connection, maintains the flow, and this TP.DT actually sends the data. Once the connection is set, you are ready to transfer the data in different packets. So until and unless the end of acknowledgement happens, you are not completed your communication. That means you are transmitting the data, and that is called you are transmitting the data more than the 8 bytes. Remember, you are not allowed to transmit the data more than 8 byte in a single frame. I am referring here multiple frames, but that frames are defining some information, useful information, and that is the multi-packets transmitted from the transmitter to the receiver. Okay, so transmit protocol provides what it provides. Basically, it provides the flow control and handshaking capabilities for the destination specific transfers using request to send and clear to send. These are the two uh, uh, messaging formats are used while transmitting and uh, clearing the communication. So flow control are basically this protocol basically provides flow control and shaking capabilities for the destination specific addresses with the help of request to send and clear to send. When it is a broadcast announce message, then there is no need for this clear to send communication. Just you start with the broadcast announce message and transmit your data subsequently. And I will make it clear why it is not required shortly. So how much is the maximum data allowed? The maximum data allowed to transfer using the transfer protocol are 1785 bytes. Now, why this 1785 bytes? What is the logic behind this? I will explain that. So transfer protocol data transfer, that TP.DT, is a 1 byte field. In this frame, when TP.DT comes into picture, there is a field reserved for the sequence number. So this is again a CAN frame. And when I talk about the CAN frame, there are the 8 byte information I can send, right? So 8 byte payload is possible. And out of that 8 byte field, the first byte is a sequence number. Always it talk about the packet sequence number, the first frame sequence number, the second frame sequence number. So first field is a sequence number. If you have the multi packets, like 5 packets, you should know that which packet is sent to be first, second, third, and fourth, and there should be order. So the first byte always talk about the sequence number. So meaning means it range from 1 to 225. If I'm saying it is a 1 byte, that means the maximum length possible is a 225. Considering the FF 0 to FF, that means 225. So it will start from 1 to 25, right? So individual message packets are assigned a sequence number starting from 1 to 25. When I say I'm sending the 4 packets, that means the first field in the transport protocol data transfer is a sequence number. It will come first, then the next consecutive 7 bytes are the actual data, right? So the calculation is very simple. This is a maximum message size of how, as I explained here, this is going to the maximum of 225, 255. And as I explained earlier, 8 bytes of the frame is possible, right? So first byte is reserved or used for the sequence number. The how many bytes are left there? That's the 7 byte in a single frame. First one is a sequence number and the 7 bytes are for the actual data. So how many packets we can send? As it is a 1 byte, 255 packets we can send. So 255 into the 7 byte per packet. That means how much the size of the actual data you are possible to send. That is 1785. Very simple calculation. So with the help of transfer protocol, you can send up to the 1785 bytes of the data, actual data you can send from the one transmit node to the receiver node. And basically this kind of communication is used during the ECU reset or the ECU programming, UDS, few of the UDS services, um, as well as the engine configuration messages or diagnostic messages where any of the ECU can sense the diagnostic trouble code. So it may happen that the one transmitter having the multiple diagnostic trouble codes. So it is not possible to send in a single frame. So they send the multiple frames, but that is packetized form so that at the receiver end, you get the proper sequence and receiver end, it decode that and understand what the information is associated with that packet. This session is mostly used for the developers. At the application end, most of the engineers use um, the application tools like Analyzer tool or the interface vehicle spy tool. So that tool is capable to decode that TP.DT and TP.CM message frames, the different packets, and it directly gives you the entire data in the analysis window for the analyzing for the engineers. But when you are a developer, if you are developing the stacks for the this scan controller, and if you want to transmit the message with a payload more than the 8 byte, then you need to understand the fundamentals of this CAN transfer protocol or how the multi-frame CAN message can be broadcasted or transmitted with the help of this transport protocol. So this session is very helpful for the developer as well as the application engineers. But application engineer, if they are using the tools like Analyzer and the vehicle spy, they can easily decode that and they can have the entire frame. But this session will definitely help you to understand the fundamentals behind the transport protocol. So let's understand the different terminologies. Till now, I have used the TP.DT, TP.CM, but there are so many terms associated when we talking about the transport protocol. So first, I'll talk about the transport protocol function divided basically into the two major functions. And that functions is a message packetization and reassembly, right? So if you have of 25 bytes of information to send, then you need to create the different packets. 25 means, as I said earlier, 7 bytes of data can be sent in a single frame because the first byte is reserved for the sequence number. And if I'm saying the 25 bytes of information, that means 7 fours are 28. We cannot send the lesser frames in the lesser, so you need at least 4 packets. So that is called the message packetization. So you need to create the packets, and that is a message packetization. And at the receiver end, it should be reassembled properly. The proper sequence should come and it should be reassembled and decoded. And the next one is a connection management. So that is very important, the role of the transfer protocol, having the two functions majorly divided. One is message packetization and reassembled, and the connection management. So let's talk about the message packetization and a reassembly. Okay. So message greater than 8 bytes broken into several smaller packets. Okay. And those packets transmitted in a separate CAN data frames, right? If you're having, as explained, 25 bits, that means you need four CAN frames. 7 fours are 28. So the 25 bytes of information can be easily transmitted with the help of the four frames. So that four is called packets. So those packets transmitted in a separate CAN data frames, basically. At the destination end, the CAN data frames received and parsed, and the original message reassembled from the received packets. That job is done by, and that falls under everything under the message packetization reassembly. And that is the job of this transfer protocol. You need to understand the fundamentals of this, how the message packetization happens and reassembly happens. Now, message packets. So packets are identified individually and reassembled correctly. Okay, and this is done by both a trans, transmitter as well as a receiver. That is a transmit node and the receiver node. Both comes into picture and they plays the role. So first byte of the data field is always the sequence number of the package, and the next seven are the data, and that is comes under the TP.DT. Okay. So next, I gonna talk more in detail about the connection management under the transfer protocol connection management. Okay. So uh, this connection management is used for the destination specific node. So transfer protocol connection management is concerned with the opening, use, and closure of the connection. What are the role? So role is actually opening the connection, use, and close the connection. That means to maintain the flow and everything. That is done by this connect, and which falls under the connection management basically. Multi-packet broadcast. Basically, sometimes we refer to as the broadcast announce messages. So large messages may be non-destination specific. If some node want to transmit the messages into the network, that messages are non-destination specific. It can broadcast to the network. So that message may be broadcast announce messages. To broadcast multiple messages, a node first transmit the TP.CM broadcast announce message. And once it transmit this TP.CM broadcast announce message, this message must be transmitted to the global destination address. So then the receiving node, which are nodes present in the network, they understand this message is a broadcast announce message. So broadcast announce message contains the PGN of a large message to broadcast, its size, and the number of packets. Okay, so this is all about, in short, about the broadcast announce message. But how this broadcast announce message is transmitted into network, I will cover in the shortly. So let's talk about this connection management for the destination address specific transfer. The connection initiates when the node transmit request to send message to a destination address. The request to send message contains the size of the entire message data in bytes, number of separate messages, the maximum number of the packets that can be sent in a response to one clear to send. So request to send and clear to send, these are the two message functions basically, or messages being used during the connection management or for the destination address specific transfers. Okay, so uh, so this in the clear to send message actually from the destination address and the PGN of the message being transmitted. So next, see the data transfer. When I talk about the data transfer begins after the originator of the connection receives the clear to send message. So in case of destination specific TP.DT, the responder is responsible for coordinating flow control between the nodes using the clear to send. For coordinating flow control between nodes using basically the clear to send. So I'm again repeating. Uh, the data transfer begins after the originator of the connection receive the clear to send. When it will start transmitting data? When it receives this CTS message from the receiver. So I'm talking about the destination specific. So once the CTS is received, then the originator start transferring the actual data, and that is into the TP.DT. The first byte is a sequence number, and second and the third byte is subsequently up to the 7 bytes is actual data. So next one is a connection closure. So two connection closures can exist. Cases exist in the absence of the errors. The first one is occurs with the BAM, that is the broadcast on the message data transfer, and the second one with the data destination address specific data transfer. So let's talk about the TP.CM more in detail. This is TP.CM is a transfer protocol connection management messages. And this is used to initiate and close the connection and also used to control the flow as well. As I'm repeating this, the reason once you understood this TP.CM and TP.DT, it is very easy to transmit the messages with the more than the 8 bytes with error, without error, as well as the destination specific, as well as destination address specific, as well as the broadcast announce messages. Very simple. So what is the role of this TP.CM? Initiate and close the connection and control the flow. So it provides the 5 connection management messages. What are that 5? First one is a request to send. Second one is a clear to send. Then the end of the acknowledgement message, and then the connection abort, and the last one is broadcast announce message. So request to send. This message always goes from the transmitter to the receiver. Imagine one of the transmitter wanted to send, let's say, 100 bytes of information. As I explained earlier, 1785 is the maximum byte of data you can transmit with the help of this transfer protocol. Now 100 bytes of information transmitter want to send, then initially he needs to send request to send message. What is the format of request to send message? What is associated in that identifier that I will cover? But this is always from the transmitter to the receiver. That is a transponder. Okay, clear to send. Once receiving the request to send message, responder receives send back the message saying I'm ready to receive the messages. So clear to send. It also tells how many packets already received and which the next packet you supposed to send. That actually it inform to the transponder. Uh, End of message acknowledgement is always sent by the receiving node. The connection abort this message can be sent by both uh, transmitter as well as the receiver. And the broadcast announce message always goes from the transponder because it is not the destination specific. If 10 issues are in the network, and if one of the issue want to send the message or is a broadcast message, so there is no destination address associated with that. So it sends first, it sends request to send, and then it start corresponding start sending the TP.DT message. That is the transfer protocol data where it sends the actual data. So these are the 5 connection management messages which are very important, and I guess it is clear for you. I repeated this frequently. Request to send, clear to send, and I again explain here more in detail about this message acknowledgement, connection abort, and broadcast announce message to you. So there are so many terms are associated with this TP.CM. Let's talk more. So let's see more in detail about this connection mode about request to send. So this connection mode request to send, it informs a node that the another node on the network wishes to open a virtual connection. So RTS request to send is a message with a source address field set to that of the originating node, and the destination address field set to that to intended receiver. So in this frame, when the request to send message will go into the network, what is associated with that? It contains the source address, it contains the destination address. Okay, and so that this is associated with that, and there are a few more fields are there, and I will explain that in more in detail shortly. Let's talk about the connection closure. So when this connection closure happens, and this is used to respond to the request to send message, which informs the originating node that the receiving node is ready for a certain amount of the large message data. If multiple clear to send messages are received after the connection is already established, then the connection shall be aborted. So there is something wrong, something is happening wrong. At that time, the connection should be aborted. Now, let's talk about the end of the message acknowledgement. So TP.CM end of acknowledgement. This message is passed from the recipient of the large message to its originator, indicating that the entire message was received and it is reassembled properly or depacketized properly. So everything information is sent by this put this message specific this TP.CM acknowledgement from responder to the originator or to the transmitter. So if TP.CM acknowledgement is received by the original prior to the final data transmission, then it ignores that. You don't care. So it is very important because transmitter knows that how many packets I have to send. When it understood, if I want to send the 8 packets, I started the communication in the request to send that saying that I have 8 packets. I have not limited the packets and I have sent, I have to send that packets. And before that, if it receives this end up acknowledge message from the responder, then it uh, ignore that message. So next one is a connection abort, and this is used by either node. As I explained earlier, both transponder as well as the receiver both can use this message to abort the communication anytime. So it is used by either node involved in the virtual connection to close the connection without completing the transfer of the message, or to prevent the connection from being initialized. So during the transmission, as well as at the time of the initialization, either of the uh, node, like transmit node or the receive node, can use this message. So I have covered 4 messages till now. I talked on request to send, clear to send, acknowledgement, message, abort, and the last one is the broadcast announce message. Okay, so this broadcast announce message, BAM message, the TP.CM BAM message is used to inform all the nodes of the network that the large message is about to be broadcast, which defines the parameter group and also number of bytes to be sent. After broadcast message is sent into the network, the TP.DT messages are sent and they contain the packetized broadcast data. Okay, so broadcast announce message is only transmitted by the original of the broadcast large message. So what have we understood from the broadcast announce message? Who sends this message? Only transponder. And transponder even does not wait for the response that is clear to send or any something like that. It does not wait. It continuously sends. Initially, it start opening the communication and then it directly start transmitting the actual data. Because this is not the destination specific. If any of the node present into the network want to process that, it may or may not be. So it doesn't wait for the response from the responder for the connection establishment. It start sending the actual data. So till now we have covered on the transport protocol connection management. There are 5 major functions, or I would say the messages are used: request to send, clear to send, end of acknowledgement, abort, And the last we talked about the broadcast announce message. That is very important. And the next I'm going to talk on that is the TP.DT. The TP.DT is actually, as name indicate, transfer protocol data transfer message. It actually carries the data. Okay. But along with the data, what it carries and how many data it carries, that I explained earlier. That is 1785 bytes of the data it carries total. And uh, there are 8 bytes of the field that's a payload associated with this frame. And the first is reserved for the sequence number. So when there is a 4 packets, so first start with the sequence number, then the next followed by the 7 bytes are the actual data. Then the next message is start with the 2, that is the sequence 2, then subsequently 3, 4, that way it sends the packages. So what is the use of this TP.DT? It is used to communicate the data associated with the parameter group. Uh, so TP.DT message is an individual packet of the multi-packet message transfer. Very simple. Is a sequentially transmitted the multi-packets basically. So it transmit 1, 2, 3 sequentially transmit. So TP.DT is only transmitted by the originator. Responder is not transmit the TP.DT. Responder may send you clear to send. Responder may send you abort, and responder sends the acknowledgement. But responder does not send the TP.DT. Okay. So next, till now I have covered the terminologies which are very important to understand how the TP.CM works, what is the use of TP.CM, and what is the use of TP.DT, how what are the different fields associated with the TP.DT. The first is sequence number, and the followed by the 7 bytes are the actual data. We also talked on the need of this transfer protocol. In the introductory part, I covered so many things like, in short, like TP.DT, TP.CM, and what is it is being used for and everything. Now we will actually see, I would say it's kind of examples, but not a real-time examples. But I will explain the sequences, and sequences I will explain with the 4 cases here. And once you understand that, I guess you are super to build the stack for this transfer protocol or develop the software for the transfer protocol. So let's start with this transfer protocol transfer sequences. So initially, I will start with the first, that is data transfer without error. Let's understand how this works. Okay. So under the normal circumstances, the flow model for the data transfer follows the sequence which I'm gonna explain you here. The originator, there is an originator. When I refer originator, means any issue. There are multiple issues in the network. This is the originator. Okay. So originator sends the TP.CM RTS. That is part of the transfer protocol connection management, that request to send, indicating there are blah 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 XYZ bytes of the packets message, which will be transmitted in the number of packets, and the PGN for that data in the what the PGN they wanted to transfer in with the component identification basically. So let's take the example here. There is a um, there is a originator, okay, and he is a transmitter, he is a responder. Okay. So here he sends the request to send message. Now what is this 1623 for, and understand this. This is a one CAN frame. One node is wanted to set the communication. So initially what it will do, it will send a request to send CAN message actually. In the request to send CAN message, here always the first byte is a control byte. So 16 is a control byte, which talks, 16 means it is a destination specific request to send message. Now we will see what is the destination just shortly. So this is a control field and is a control byte. Basically, it's a 1 byte. So out of the 8, but I'm explaining all the 8 bytes in the request to send message. First is a control byte. It's a 16. Then second and third byte is always talk about total message size or number of bytes which I gonna transmit. Here 23 means 23 bytes of information this originator want to transmit into the network to the specific receiver, right? So second and third byte is here. So till now I have covered the 3 bytes. The fourth byte. So here we have to transfer 23 byte of the information. And the next one is talk about the packets. So considering the 23 byte of information, originator node itself calculate how many packets I need to transmit. If I want to transmit 23 byte of the information, that means I need to send the 4 packets, right? So this fourth byte is total number of packets. 4 means four packets needs to be sent. And the fifth byte is a number of maximum number of packets that can be sent in response to the clear to send. Here originator can limit that also, but here it is open. FF means you whatever the packets ideally the originator node needs to send, all that packets are getting sent here. So this is the fifth byte of the request to send message. So and 678 out of the 8 bytes, 678 are reserved for the pigeon. And here the pigeon is 65259. We are talking about 65259 pigeon here. So I guess it is super clear now. What we are doing, we are sending um, the 16 destination specific request to send message. That is the control byte is defining. And what is the total message size? It's a 23 bytes, number of bytes we have to send. And for that, we need a 4 packets. So originator will send 4 packets. And we don't want to limit the number of packets that can be sent in the response of the clear to send. So that's what it is open to 55. And this is the PGN associated with that packeted message. So PGN of the packeted message. All this information is sent by the originator node. Now, responder node, what will do? Let's start. Let's see what will happen next. So here the connection is initialized. Okay, there are some timing parameters are associated with this. So before or at the time of 200 millisecond, it will respond. Who will respond? The responder will respond with this. That is the clear to send message. Here request to send, clear to send message, right? What is it is responded 17 to 1. Let's decode that and I will explain you. So when the connection mode clear to send message comes from the responder, the first byte is always control byte. So it is again destination specific, clear to send. And the second byte is a number of packets that can be sent. Now, here we want to send the 4 packets, but here the responder is ready to receive 2 packets at the moment. So it is sending respond to the originator node saying that number of packets 2 can be sent at the moment. Okay. So third byte is talk about the sequence number, basically the next package number to be sent. Why it is 1? Because till now, none of the packet is received. The actual data is not received. So that's what responder is saying. Send the first byte, and I want only 2 packets at the moment. Right? This is a control byte, and this next byte is actually fourth and fifth is reserved. So this fourth and this fifth is reserved, and that's what this is 255 255. Reserved means FF, and the last that is 678 is a pigeon of the packeted message, and the same pigeon responded whatever the pigeon is here in the request. That is not a request, but it's a yeah, it's a request to send. That is the pigeon of the packeted message. Same is responded here. Clear? This is a control byte. Then this is the number of packet that can be sent. That's the 2 packets can be sent now, and the one is talking about the number of the sequence of the packets. The first initially send the first packet. This is result, and the pigeon. Now let's see how the originator responds. So we are looking for the data transfer without error. How it happens for uh, the message which has the data byte data bytes more than the 8. So here the connection is established now. So after this time, it responds. After the 1250 millisecond, it responds with the TP.DT. Now, as I explained earlier, the first bit is a sequence number, and followed by the 7 bytes are the actual data. So here it started sending the actual data. And here what is requested? I am expecting only 2 frame at the moment. So, and this response is getting before 200 millisecond or at the 200 millisecond. And after the 200 millisecond, the second uh, data frame is actually sent. That is the TP.DT is sent. So the responder had received the 2 packets, right? Now, ideally, what should happen? Here initialized, we want the 4 packets. So still we have not finished the communication. And even the responder knows that I need to receive the 4 packets. So I'm again waiting for the few packets. So ideally, what should happen now? Let's see what happens. So the time duration between these 2 packets at the responder node is defined the 750 millisecond. And after receiving the second packet, it waits for uh, 200 milliseconds or less than that, within that time or before that, it responds back with a clear to send message. Okay. So what is here defined? 17 control byte. Okay. And this byte talks about the number of packet. But you see here, what he's saying? You send. What is the number of packet that can be sent? Zero, zero packets. He's saying that send the 0 packets, right? So let's see what will happen when this such kind of response will come. That means after this time, it will wait for 1050 millisecond, and then nothing will happen from the originator because he's saying 0 bytes, right? He's not telling us how many number of packets that can be sent. It's saying 0. That's what originator will not respond. It will wait for this time. And within that time, after 500 millisecond, the responder is ready to communicate with the originator saying that I need 2 packets, and which packet I want? I want the third packet because I already received 2 packets. These 2 packets are received. So here it is talking, send the third packet now, right? And now let's see what happens after 200 millisecond time. Or before that, the originator or the transmitter node responds with TP.DT, saying that this is the sequence number of the actual packet. That means the actual data packet, and here my data. So here started with the 1 to 7, that's a 7 byte. Then again the next 7 byte, again the next 7 byte. And here we have requested, that means the responder has requested send me the third packet. I mean, start with the third packet and the two I wanted to um, 2 packets. So after it will wait for this time, and that's 200 millisecond, and it will send again the next data, right? And that's next packet. So here 24, I mean, we were expecting the total 23, and here the 23 is received. The total data is received. Now the responder knows that I was expecting the 23 of the total message size or the number of bytes, and I have received that. So what ideally it should do if there is no any error? So ideally it should acknowledge that I have received everything. So in the acknowledgement, it then communicate that I have received everything. So now this everything is done and the connection is aborted. That means the proper transmission is done for the 23 byte of the data. Okay. So have you seen how the 23 byte of the information is sent sequentially, and that is called the multi-packets with proper meaning? Because if you randomly send the message, and if one of the signal is taking the last byte of this frame and the first byte of this frame, and if you receive the third frame instead of receiving the second frame, that may at the time of decoding, it will get the wrong decoding right at the responder node. To avoid that, this protocol is defined. It talks about the sequence number. If something happens wrong or some request happens, the originator node also knows that how many packets are transmitted, how many has to send, and how many has been acknowledged. So everything is defined in the transfer protocol. So without any error, the 23 data bytes of data is transmitted here. Now, the one point I would like to highlight here, when mm, here I'm talking about the sequence number and the actual data. Now, suppose there is a need to transmit only 3 packets, and instead of 23, if uh, my need to transmit the total number of packets are, let's say, a total number of bytes, let's say only 16. So here the can frame will definitely go there. The 15 will get sent, the 16 will get sent. What about the rest bytes? Because this is a can frame. First byte is used, second byte is used for the data, first byte is used for the sequence number, second byte is used for the data of the 15 byte, and then the third one is used for the data of the 16 byte. But what about the rest field? The rest field, the originator pads with the FF, and uh, that is the value is paid by this byte should be filled with the FF. If there is no any assignment or there is a the frame is remaining empty at that time, the FF is fed into the frame. So I guess this is super clear. So let's take the one another example. If you are not clear, please repeat the video and try to understand. Once this concept is clear, you can easily go and start implementing your transfer protocol, engine configuration message, diagnostic message 1, message 2, message 3, or any flashing of the ECU, programming the ECU, or the reset the ECU. That can be done with the help of this. I mean, with the help of this protocol, you can do that. Let's see the another example, that is the data transfer without, with error. Now we have seen without error. Now let's see with error now. Okay. Now I will not talk about the timing parameter. Let's understand the fundamentals, and you're super clear. So if you want to do the programming, what are the timing parameters? Please go back to the just 2 minutes, 2 to 3 minutes back and understand the timing parameters. So here I'll talk on how the sequence works when there is error, with error, how the data is getting transmitted. There is a originator node and the responder. Now here the clear to send request to send message is initiated, and that what is the first byte? It's a control byte. Again, it's a 16. 23, that means number of bytes needs to be transmitted 23. The 4 means for transmitting 23 bytes we need a 4 packets that this originator node has already calculated. And then there is, we are not setting up the limitations on the number of packets that can be sent in the response of the clear to send. So it is open. So that's what 255, and then 6 to 8 byte out of the 8 field, 8 bytes of the data field of this request to send message, 6, 7, 8 are the PGN. So this is a PGN of the packeted data actually. So let's see what happens. So a connection is established, connection is initialized here, and connection is initialized here, and with that respond, we got a clear to send message. First byte is control byte. Second field is talk about the number of packets that can be sent, right? So at that moment, the responder is saying that I am ready with the responding you with the two packets, right? And the here it talks about the sequence of the packet. So he's saying, send me the first packet, and fourth and five are reserved. That's what it is, the 255, 255, and this is standard. So if you go back with the data transfer without error, I explained the same thing, clear to send. This is reserved, this is reserved. And here we talk about the pigeon of the packeted message. Okay, so this is done. So connection is established. Now let's talk. And now it is started transmitting the data. So expecting the two um packets. So the first is sent, the second is sent, the data is associated with that. This is sequence number, packet 1, packet 2, right? Now, for the third time, you see already it is received the packet too. But again, he is expecting that you send me the one packet, and 17 is a control field, and number of packets he is expecting the one packet, and it is telling to the originator node saying that I want next packet that is a second to be sent, and already it is received the second packet, right? So this is basically error. So mm, the originator understand that there is an error, so it respond to that. It's saying, I mean, with the same packet, whichever the packet is expecting, the second packet, and only one packet is expected. And here it then start saying that I need two packets and start with the third packet because already it is received the two packets. So without any error, it responded, and the third packet and the fourth packet is received. So the total 23 bytes of information is received in a 4 packets. Here 4 is packet number, 23 byte, control field, and this is the PGN. And here it is maximum number of packets that can be sent in the response to one clear to send. So we are not putting any limitations. Why I'm repeating no limitation, no limitation? Because many times as per the need, originator can limit this. Though it wants to send 23 byte of information in a 4 packets, it can limit the clear to send response. It can reduce this number, and I will explain in the upcoming time. Shortly, I will explain you. So I guess this is also super clear. So what is this end of acknowledgement? I have not explained the previous, but I will explain here. What is this acknowledgement and what is the meaning of each and each every byte, and the same for all with error, without error, as well as for the broadcast announce message as well. But for the broadcast announce message, the acknowledgement message is not applicable, as that is the announced message, broadcasted message into the network. It is not a destination specific. Wherever the message is a destination specific, we expect the acknowledgement from the destination, from the responder node. So in the previous session, when the data was transmitted without error, there it was applicable, and here also it is applicable. So let's decode this. What is the first in the acknowledgement field? In the acknowledgement, the first is fixed, that's the control byte. Whenever there is 19, that means it's the end of acknowledgement. It's a control byte. 23, this is a number of bytes. That is the total message size. So requested 23, received 23, right? Then the 4 is a total number of packets. So here initiated the total number of packets 4. Here it is reserved total number of packets 4. And this fifth is reserved. When I say reserved, that means we have to set FF. FF means 255. And the last 6, 7, 8 byte out of the 8 bytes payload, the 6, 7, 8 byte are used for the pigeon of the packeted data or the packeted message. That's it. This is how the end of acknowledgement message is decoded. I explained the request to send, clear to send, how to decode the end of acknowledgement message, how to decode the TP data. It's very simple, very easy, done. So let's move for the next, and that is broadcast announce message. So basically in this situation, which I'm gonna present now is a node which indicates to the network that it is about to transfer the multi-packet message utilizing the services of the transport protocol. So in this example, I'm gonna using the PGN 65260, and it is a standard G1 standard, which is to talk about the vehicle identification number. So it's being broadcasted to the network. So this PGN 65260 vehicle identification is being broadcasted to the network. The originating node first transmit the broadcast announce message, followed by the data packets. So there is no any acknowledgement or any response in terms of the clear to send expected, because this is the broadcasted message. So let's see how happens. So originator node, and the responder node. So I gonna not talk more in detail about the timing parameter, but you just note the timing parameters. In the broadcast announce message, when the first this broadcast announce message is sent, um, what is this field? The first field, 32. So this is a control byte. When we define this value 32, that means this message is 100%. It's a transport protocol connection message broadcast announce message, connection management broadcast announce message, and it's a global destination. Okay, so 32 is a control byte. Then 2 and 3 are reserved. So this field is talk about 2 and 3 are reserved for, I mean, not reserved but used for total message size, number of bytes which you want to transmit. So here I want to transmit the 17 bytes. And then this talks about packets. For transmitting 17 bytes of information, how many packets I need? I need a 3 packets. Already originator had calculated that. And this is reserved basically. So the value is FF. And as I explained earlier, 678 is a talk about PGN of the packeted message. So here it is started after the time of 200 milliseconds, starting from 10 to 200 millisecond. Within that, it responds. I mean, originator start transmitting uh, the actual packets, actual data. It does not wait for any response from the responder. Okay, so here it started transmitting the data one, and after this time, that's it. After waiting 10 millisecond to the 200 milliseconds, so maximum is 200 millisecond. Before that, if it does not send, that means the timeout occurs and the error, and sometimes the connection abort as well. So that's what the timing parameters are important. So this way it goes, and at the receiver node, you have time to fetch that data before 7.5 seconds. Within that time, you can fetch that data and process. After um, from 10 millisecond to 200 millisecond at any time, the next packet can be sent. So this is how the all packets are sent. This is a broadcast announce message, broadcast data transfer. Okay. And the last I'm gonna talk is a data transfer, which is utilizing request to send maximum number of packets capability. Now I gonna limit the packets. So let's see how it works. So here is my originator, and here I send the request. Okay, so it is clear when the request goes. The first is a control field, control byte. Then here 2 and 3 talk about the number of bytes I want to transmit. Here 44 bytes needs to be transmitted. How many packets are required? 7 packets are required because each packet consists 7 bytes of information. One is reserved for sequence number. And then this is a maximum number of packets that can be sent into the response. Ideally, originator node wanted to transmit 7 packets, right? Total number of packets are 7 required to transmit 44 byte of the information. But originator itself limiting, saying that I only need 5 number of packets that can be sent in the response to the clear to send. And this is the PGN, which are PGN of the packeted message. So let's see how the response comes. That's what it is also responded, saying that um, control byte is 17. Uh, that is the number of packets that can be sent. That's the 5 because here you limited. And then 1 is 1 is a new packet number to be sent. Okay, and these are reserved, and this is again the PGN. So here the first data sent, the second data sent, third, fourth, and fifth. What is the difference between earlier explanation and here? Here you are telling specifically to the responder, I want the 5 package. Okay, timing parameters are definitely associated with that. And you see it responded with the 5 packets. Earlier responder was taking on their time, and accordingly it was responding. It was responding with the 2 packets, and accordingly the originator node was sending the packets. But here it is asking for the 5 packets, and that's what it is. Here it is not open. That's what as you set the maximum number of packets that can be sent in the response to clear to send. We are telling for clear to send message that I want the 5 messages. That's what here you get 5 message in the response, and 1, 2, 3, 4, 5. So as soon as originator receives that clear to send message from the responder, it starts sending the actual data. And finally, as we limited because we want the 7 and we want the maximum size of 5. That's what I'm talking about, data transfer utilizing the request to send maximum number of packets capability. At the bottom, I have titled that data transfer is happening how it is utilizing the request to send maximum number of packets capability. So here then I needed 2 packets because already received 5 packets. Total packets are 7. So how many packets are left? 2. He received the 5 packets. The next packet should be start with the 6th packet. So here the 6th packet will come and the data will accordingly come. Here 1 to 7 byte, remaining 8 to 14, remaining 15 to 20. So already we have received 35. So 36 starting from 36 to 42. And then the 43 to 45. And as I said earlier, only 2 bytes are used out of the 8 bytes. 3 bytes used. One is sequence number and these 2 are data. How many left here out of 8? There are 5 left. 1, 2, 3, 4, and 5. And you cannot, or the originator node cannot leave it blank. You means whoever is the programmer, who is writing the program. So at that time, you have to fill this value as a 255. That is FF. You cannot leave it blank or 0. You need to feed that value so that the responder understand that it is that means we have to ignore that and this is the actual data. And then you get the acknowledgement. Acknowledgement tells about the associated packeted PGN of the packeted message, and then it talks about the control byte, then the total message size, that's the number of bytes, that's the 44. And as we requested at 44, reserved the 44 packets, number of packets, how many packets received? 7 packets. And here the reserved for assignment by the SAE. Basically it may be used for the future purpose, but today we have to set this FF, that's what FF, and this is PGN of the packeted message. So I think this is all I do have for today to make you understand how the transfer protocol works. What is the TP.CM? What is the term associated with that? Clear to send, request to send. Then what is acknowledgement message, abort, as well as I talked on the broadcast announce message, TP data, sequence number, and the actual data. So with the help of this protocol, you can send more than 8 bytes, meaningful in the multi-packets, and that packets are assembled, reassembled at the receiver node and decoded as per the need. That's the beauty of the scan protocol. I hope you will start using this scan protocol. As soon as you see the D1 message or the EC1 message in your canalizer or the vehicle's fire network, definitely you will relate how that multi-packets are created, multi-frames are created with the help of this transfer protocol. I hope this session will definitely make you aware the fundamentals behind the theory behind how the transfer protocol works and what is the use of this transfer protocol. So if you, I always, as I mentioned earlier, I would like to know always what was the valuable for you inside this knowledge sharing session. Really, I'm making something interesting for you to learn. And what was your most valuable takeaway from this session? Tell me in the comment box to be my next viewer of the week, and I'll see you in the next session. I'll bring something interesting for you. So thanks for your time, and please like, share, and subscribe to my channel. Thank you.